Hi geometry students, I hope you had a good weekend and we're now going to do lesson 12.5. I hope also that you enjoyed our little hands-on activity, seeing that 3 pyramids put together make a cube, and that's how we generate the formula for the volume of a pyramid. So anyway, I am ready to get started and I hope that you are too. Father in heaven, we just thank you for this day. I pray for all my students that you would help them to focus, to learn really well, to understand everything that I'm teaching so that they have great success on their test. And I pray for myself that you'd strengthen me and help me to be the very best teacher I can be, using words that would explain things the best. In Jesus' name, amen. Okay, well, let's get started and sit down. Here is the projector, and I already wrote down all the pictures to save us some time. And so whenever you want to pause the video and draw a picture or write something down, you are welcome to do that. Okay, so as you saw through our hands-on activity, the volume of a pyramid is V equals 1/3 area of the base times the height. And we've talked about this before, but the big B stands for base area. Okay, and the volume of a cone is the same, except they point out that the base area is the area formula, pi r squared, of a circle. That's what makes a cone, a circle on the bottom. Okay, so we're going to do some examples now. I already drew my picture for number 1. Find the volume, and this is an M for meters, so you can go ahead and draw that triangular based pyramid, and let's get going on it. Okay, so the volume is 1/3 base area times height. Now my base area is the formula 1/2 base times height, and the base and the height being of the bottom shape. So I've got my base here, that's the little b, and the height is here, and we know that because I have my little perpendicular or 90-degree symbol there. So first thing I do is find the base area, so that's going to be 1/2. And the base then is 4, and the height of the base, be careful, that's different than the whole shape, is 6, and I work that out and I get 12. Okay, so that's the first thing you want to show your work on. And now I'm going to compute the whole thing. So the base area is 12, I put that in here. And then the height of the pyramid is that height that goes from our point on top right through the middle to the center of the base, okay? So that, or somewhere in the middle of the base, not always the exact center. So that's going to be 9. And when I work that out, I get 12 times 9 is 108, divided by 3 is 36. Okay, and it's very important, your units are cubed this time, because we want not the surface area on the outside, but the volume, which is all the space on the inside of a 3D shape. Okay, let's do number 2. This time we have B, which is a right cone, and here's the top, and I have a circular bottom. You can pause the video for a minute if you want. And we're going to have the volume is 1/3 base area times the height. So that is 1/3 pi r squared h. So then r is 2.2 centimeters. So I'm going to have 1/3 times pi, which is 3.14. Now I've noticed in some of my answers, at least in the examples in the front part of the book, that they're using 22/7 for pi. They're not rounding it. So you will get a slightly different answer. That doesn't mean it's wrong. I am totally fine with rounding to 3.14. Okay, so I'm going to put 2.2 squared in for the radius, and then the height is right here, perpendicular to the base. which is 4.5. Okay, so I have 1/3 times 3.14, and 2.2 squared is 4.84 times 4.5, and when I work that out, I get 22.81 centimeters cubed. So that's my answer. It's just like the prisms and the pyramids, except you're now going to divide by 3. Okay, now you can see I've already started the notes for the number 2. It's about a Great Pyramid, so I have a picture. Look at that. Isn't that spectacular? This is the Great Pyramid right here. Can I draw on that? The Great Pyramid of Giza, it's called. It's King Cheops, and it has the alabaster up on the top. The whole thing was covered with alabaster originally, and so when the sun would shine on it, it would be so bright you couldn't even look at it. And then later, a lot of the alabaster has been stolen off of it, and that's why you see there's a little bit on the top and then off the bottom. Now, the reason why I chose this picture is because of the camel. This is an actual place. Now, I think it has been modified a little bit to Photoshop to make it look really good, but there is a camel in the picture because I have been there. When I was 13, it was 1979, and I got to go to Egypt, and I got to ride a camel around the Great Pyramid of Cheops. It was really quite an experience, and it is a gigantic pyramid. And we got to go inside, go all the way to the funeral area, and you can see the sarcophagus, which is what they put the body in, kind of like a coffin. And there were lots of tunnels because they would create tunnels so that thieves, that were fake tunnels, so thieves would be trying to get in the wrong way, and to protect all the wealth and the body of the king. So it really is just one big shrine to the king who had died. So anyway, our province involves this, so you can watch this. I'm going to read it out loud. Originally, the Great Pyramid of Giza had a height of 144 meters. So that's around 5,000 feet high. It's a lot. Or no, I'm sorry, 500 feet high. That's still very high. That's like 50 stories. And a volume of 2,226,456 meters squared. Find the side length of the square base. Okay, so now we're going to go back to our notes. Here's the relevant information. I already wrote it down for you. If I can ever get this to move again. Hello, it's telling me to customize this page. Why is it telling me to do that? Okay, maybe we'll get it back now. Here we go. Okay, so the Great Pyramid was 144 meters high, and its volume at the time was right here. And we're going to find the length of the square base. So we want to find this. It was a square base. So we're going to start with our volume formula, and then we're going to figure everything out. So I am told the volume already, and I have 1/3, and I'm told the height right here was 144. This is a little bit out of order. What I don't know is this length here. Now, how do I find the base area if it's a square base? It would be length times width, or side squared, because they're the same length. So side squared we could represent as x squared, because I don't know it. You can use s if you like. I don't like using s very much because it looks too much like a 5. But you can use x2 because we don't know this side length. So I'm going to put x squared here. All right. So now I'm going to try to solve for x squared. I want to move all the numbers away. So the first thing I do is divide 144 by 3. And I get 48 squared. Now I'm going to divide both sides by 48 and I get 46,384, and that equals x squared. So x will be by itself. And then the last step is I take the square root and I get x is approximately 15 meters long. That's very long. That's over 600 feet long. It's a very big structure. Okay? All right, I want you to try some on your own. So why don't you go ahead and draw this picture. We have a hexagonal pyramid. Okay, and so that means this length is 4 and the height going up is 11. So you're going to have to figure this out. Do you remember this from chapter 11? We're still doing that. It's a hexagonal shape, so we know we have 6 sides and it's regular. And then the other figure is a right cylinder. Now be careful, we don't have the radius. You're going to have to find that. Okay, so I'm going to pause and you guys can go ahead and work on these and we'll come back in just a moment. Alright, so now my formula, I don't have too much room. I'm going to really work over here, is 1/3 base area times height. And my base area is going to be my formula 1/2 ANS. And that is, A is for anthem. So do you remember if I draw a little triangle in here, now I'm going to draw it bigger over here so you can see it. And this length here is 4, okay? Now I divided up into 6 triangles, so I only have one length. So what do I do when I only have one length? Do you remember? I use the angle measure. So what I need is this angle right here. So I have a total circle degrees is 360 and I divide that by 6, so I get 60 for one of the triangles, right? But that's both. That's from here to here. So I have to cut that in half and get 30 degrees. So this angle right here is now 30 degrees, okay? Whoops, not square, 30 degrees. All right, and this is 4 all the way across, which means this is 2 and 2. So be careful, don't use 4 in your trig function. So I'm going to have tangent of 30 equals 2 over x, opposite over adjacent. And the tangent of 30 is 0.5774. Okay, I need to get x alone. So first I have to get it out of the denominator. So I've got 0.5774x now equals 2. I'm going to divide by 0.5774. And what I get for x is 3.46. So that is my apothem, sorry, apothem. Okay, now I'm going to go back over here. My base area is going to be 1/2. Now I know the apothem, so that's 3.46. I've got 6 sides, and each side length is 4. So when I multiply 1/2 times 3.46 times 6 times 4, I get 41.52. Okay, I'm running out of room. I'll work over here and then I'll erase it probably. Okay, so I have now the volume is 1/3 times the base area, 41.52 times 11, which is the height, right? And if I work that all out, I get 152.42 yards cubed. So really, the hardest part of this problem is doing the base area, the hexagon, right? I know you were hoping to probably want to forget that, but it comes back, so we can't forget that. And that's okay, because you're going to need it for the future in math. All right, so let's do the next one. I am going to move this over here, and they are outside playing ping pong right now, making a whole lot of noise. So I am going to go and close the door, and I want to go play ping pong too, so let's keep going. All right, so the door's closed. We won't have any loud noises. We do everything loud in my house. So let's do number 2. So my volume is going to be 1/3 pi r squared h. So then this is 3.14. Now hang on a minute. Oh, I have this written wrong. I am so sorry. I'm so sorry. Well, let's just do it the way I had it. Okay, we'll just leave it. All right, so I don't know the radius, and I do know the height, 5. How am I going to find that radius? I need the radius. Well, I have a right triangle here. So let's work that out. I have 5 squared plus r squared equals 8 squared. So that's 25 plus r squared equals 64. And I get 39 is r squared, and that means r is 6.24. Okay, so let's work it out. 1/3, 3.14, and then I'm going to square 6.24 times 5. All right, so let's see what happens. Let's see, I've got 6.24 times 6.24, and I get 38.94. I'm going to round that there. So I've got 3.14 times 38.94 times 5 equals, and I get 611, divide that by 3, and I get 203.79. And that is, these are centimeters, so this is centimeters cubed. Okay, so those are your OIOs. Let's keep going. Let's do number 3, way back over here. Now, I'm going to have a volume, and I am trying to find the volume. And with what's given, do you see here, I need to find the radius. And I'm going to use trig. So this angle is 65. So in order to find that, find r, I need to use trigonometry. So from this angle, I've got opposite over adjacent. So that's tangent function. So we're going to have tangent. Oh, by the way, not insulted. You need to pause to draw the picture. Go ahead and do that. Cut me off anytime. All right, what I don't know won't hurt me. 65 equals 16 over r. Okay? And let's see. Tangent of 65. I want to check that. Yeah. Okay. So this is 2.14. Now I want to get r out of the denominator. So these cancel. 2.14r equals 16. divide by 2.14, and I get a radius of 7.48. Okay, so that's my radius. Now I'm going to work that into my volume, which is pi r squared h. So I have 1/3 times 3.14, and now I know my radius is 7.48 squared times 16, my height here, right? 16. So when I work that all out, I get 936.976, and it was units. So that's units cubed. There's my volume. All right, now, sometimes we have a figure like this, where we're going to have two 3D shapes on top of each other, okay? So I've got the pyramid, which is on top here, and I have the cube, which is down below. So I'm going to have the volume of the pyramid plus the cube. That's going to be my plan, all right? So I want to work that out. So the volume, I'm going to have the cube, which is 1/3 base area times the height. And I'm going to have the cube here. Did I say pyramid? I meant my pyramid. So then I have the cube. Now I know it's a cube because all these lengths are the same, right? I've got 6, 6, and 6. So that's going to be side cubed. That's my formula. All right? So I'm going to have 1/3. Now, what's the base area? Well, I have a square. So that's going to be 6 times 6, which is 36, right? My base area of my pyramid, it'll be the same as the base down here. If this is 6, then this is 6. And if this is 6, then this is 6. So here's my base area, right? Does that make sense? 6 times 6 is 36. And then the height